really, it can be really easy to confuse yourself on things. So I'm trying to keep it as basic, as simple as possible. And this first type with these charts, I think it's the easiest thing to do. So we've got two girls, Maggie and Elizabeth. They both have M&Ms. And then it separates in this table their like proportion, their percentage, their probability of having those types of M&Ms. So like Maggie has 0.3 is the probability that she has a green, which means 30% chance that she has a green. And then so on and so forth. And if we were to add these up, they should equal 1. If we add these up, they should equal 1. So just like I was saying, if a candy is chosen from, oh, this time I'm looking at Elizabeth. Elizabeth's bag, what's the probability it will be green? So under green, she has a 0.2. So it's 0.2. If you want to think of it as a fraction, it'd be 1 over 5. If you want to think of it as a percent, which is what most of us, I think, naturally think of it as, it's 20%. Probability is 20% that we will pick a green from Emily's bag or Elizabeth's bag. Next, if it's chosen from Maggie's bag, what's the probability it will not be yellow? Well, what's the probability it will be yellow? 0.2. And so if I want everything that's not yellow, we can think of it as 1 minus 0.2, which is going to be 0.8 or 80%. Okay. If a candy is chosen from each bag, what's the probability they will both be red? What's the probability it'll be red from Maggie's bag? 0.2. And from Elizabeth's bag? 0.3. We're going to multiply when it says this, they'll both be blue. We're going to multiply those together. So it's like the same situation. It's the same like time that we're pulling them out. We're going to multiply to get both and them to be the correct answer. When you multiply, be careful. I thought it was 0.6. It's 0.06, which is about 6%, not 60%. Those are two very different numbers. All right. If a candy is chosen from each bag, what's the probability that neither will be brown? Well, what's the probability that you'll get a brown one from Maggie's? What do you say? 0.2. And so what's the probability that we will not get a brown from Maggie's? 0.8. Same thing for Elizabeth. It's 0.1 to get a brown for Elizabeth. So what's the probability of not getting a brown? 0.9. Very good. And that will be 0.72 or 72%. Everyone good so far? Okay, next one. If a candy is chosen from each bag, what's the probability that the first one will be green and the second one will be blue? Okay, so this says that order matters. And since Maggie's bag is listed first, we're going to assume that we're always pulling from her bag first and then Elizabeth's second. So this means that we can only try the situation where we get a green one from Maggie and a blue one from Elizabeth. What's the probability we get a green one from Maggie? 0.3. What about a blue one from Elizabeth? 0.2. So 0.3 times 0.2, and I get 0.06 or 6%. Now, that's different than if I just pulled out an M&M from each bag and I got a blue and a green, right? So if it didn't matter which bag I pulled which one out of, I can still check that probability, and that's what the next one is asking. If a candy is chosen from each bag, what's the probability that just one of them will be blue and one of them will be green? This time we have to try both things. We have to try, okay, what if we get a green one from Maggie and then a blue one from Elizabeth? That's what we just found, right? We just found 0.3 times 0.2. Also, I'm using those little X's to multiply because there's really no variables here. You can use parentheses or you can use dots, but I thought that was going to get confusing. And then it's also okay if instead of pulling a green from Maggie and a blue from Elizabeth, if I pull a green from Elizabeth and then a blue one from Maggie. So I have to also try that one, which is going to be 0.2 times 0.1. Since both of those situations are okay, a blue from Maggie and a green from Elizabeth, or a blue from Elizabeth and a green from Maggie, we're going to add those two situations together. Both of those are okay that they happen, but they're two different situations. So we can add those two together. That is 0.06 plus 0.02 which is 0.08 or 8%. Anybody questions yet? I've got one more like this. The last one, it says if a candy is chosen from each bag, what's the probability that neither will be red? Well, what's the probability neither will be red from Maggie? What's the probability that that it will not be red from Maggie's bag? 0.8. Very good, Hadley. What about from Elizabeth's bag? 0.7. Anybody questions on how Hadley knows those? Okay. Which is 0.56, which is 56%. All right, that's all that type of problem. I think that's pretty simple. Anybody have any questions yet? All right, the next one, for the rest of the class, we're going to do problems where we're considering the fact that we're being dealt a 5-card hand of cards. Let's go over some basics, okay? You don't have to take these notes, but every year I get somebody who's like, well, I didn't know something. I'm like, I can't teach you everything. So let's review. How many cards are in a deck of cards? 52. How many suits do you have? How many colors do you have? 2. 4 suits, 2 colors. How many of each suit do you have? How many cards are like hearts? 13. I knew Parker was doing some mental math over there. So there's like 13 of each suit. What if I'm thinking about aces? How many aces are there? 4. So 4 of each like type of card. What else is important with cards that I could ask you? What counts as a face card? King, queen, jack. The only ones that have faces on them. So not aces, no nothing else. How many face cards are there? 3 different types, and then there's 4 of each. So there's a total of 12 face cards. I think that's really it. Every year that I have somebody who doesn't know how many suits or how many colors, and I'm not having that conversation. So I love a good game of cards, and I thought everybody's learned at least one card game, right? Yeah. It's like some basic elementary school stuff we teach you. Okay, so we're dealing cards. We want to know how many 5-card hands are possible. Anyone have a guess on what we've been doing so far, how I could find all of the ways that I could pick 5 cards for a hand? When I'm dealing, does it matter what order I deal it in? Like if you get 5 cards, does it matter that like ace is the first one that was given to you and then like 10 is the next one given to you? No, right? Because they're all going to go in your hand and then you shuffle them around anyway. So order doesn't matter. We're going to do 52, choose 5. If you remember back in 9.2 last week, I taught you about permutations versus combinations. Combination is where order doesn't matter. You just told me it doesn't matter in my 5 cards if I got ace and then 10, or if I got 10 and then ace. It's still in one hand. So that doesn't matter. So that's why we use a choose. And then I have 52 to choose from, and I have to pick 5. If you do that in the calculator, we're going to do that one in the calculator really quick. We're not going to do most of these out, but we'll do at least this one. I have it up here. 52, choose 5. I got, is that 2,598,960? I'm not great at numbers, but I think that's how you read that one. 2,598,960.
How did you get this?
You press math, and then you scroll all the way over to PRB, and then that third one says NCR. Sometimes you have to put the number first. So like I might have to type 552 and then come find this one. So if you have any question on how to enter that in, definitely come ask me. Okay. All of the rest of these, at least that we're looking at today, say what is the probability of something, something. Remember earlier at the top of your page, I told you that probability is success over total. Success over total. So all of these, we're essentially finding the success. Like that's kind of the question for each one. Like when are we going to be successful when we have these cards? But the total that's going to be involved in every single answer is 52C5. So all of these are going to be a fraction, and in the denominator in all of these problems, it's going to be 52 choose 5. Okay. What we're kind of asking ourselves then is like, what goes on top? I don't need my calculator because I'm not going to plug anything else in today. Okay, it says, what's the probability of being dealt a hand with all diamonds? Okay, how many diamonds are there? 13. And how many do I want? I want 5 of them because I'm just getting 5 cards in my hand. So I almost always want 5 as my final answer until we, keep going. So 13 choose 5 over 52 choose 5. That's it. You can plug that in and find the actual probability, but that's what I'm looking for. Okay. The next one, it says, what's the probability of being dealt a hand with all face cards? Again, put your 52 choose 5 on the bottom. How many face cards are there again? 12. And how many do I want? 5. 12 choose 5. All right, probability of dealing an all red hand. Okay, it's all over 52 choose 5 again. How many red cards are there? 26. And how many do I want? 5. 26 choose 5. All right. Everything so far has been like we want all of our cards to be something. We wanted them all diamonds. We wanted all face cards. We wanted all red. Now, the next few, we're going to have kind of specific requirements. I don't want all something. I want 3 jacks and 2 kings. This is true for one hand. So I'm going to have 2 different chooses on top, and I'm going to multiply them together because this only is like one situation that works. 3 jacks and 2 kings has to be true in like one section, one hand, I guess. I'll show you what happens when we add them, but right now it's multiply. So how many jacks are there? And how many do I want? So 4 choose 3. And how many kings are there? And how many do I want? 2. Good. 4 choose 2. And then it's all still over 52 choose 5. Okay. The next one says, what's the probability of being dealt a hand with no face cards? How many face cards were there? 12. So if there's a total of 52 cards and I don't want any face cards, how many cards do I have left to choose from? 40. Good, Quiva. So I'm going to do, and how many of those non-face cards do I want? 5. I have nothing else on top besides just 40 choose 5 because I want them all to just not be face cards. And then on bottom, it's still 52 choose 5. Okay. Next, I have what's the probability of being dealt a 5-card hand and having all the aces? Okay. How many aces are there? 4. So we want 4 choose 4. But how many cards am I supposed to have in my hand? 5. So I need to get another card. Is there any rule on what my other card should be? No, it doesn't have to be red. It doesn't have to be a special number. It can be anything. If I'm thinking about anything that's not my ace, how many cards are left if I've gotten rid of all 4 aces? 48. So it's going to be 48, choose just 1. This would be a smaller number if it said all aces and a red card. Then that would be a different number. But this is literally every card but the aces. And again, we're going to multiply because this is true in your one hand, not two. Not multiple hands that are okay. Like this is the only hand that works. And again, 52, choose 5. All right, last one we're going to do. It says 2 tens, 2 jacks, 1 queen. How many, what was it, tens? How many tens are there? Good. How do I represent that I want 2 of them? Other way around. 4 choose 2. Good. How do I represent the 2 jacks? Same way, 4 choose 2. And then how do I represent the 1 queen? 4 choose 1. And all of these are multiplied because it's true in one hand. And then it's going to be 52 choose 5. We'll get down later on. But do you see here, I'm going to talk about letters K really quick. Do you see how it says the probability of being dealt at least 4 spades? That's going to be where I have a plus sign, because it'll be okay if I have 4 spades, but it will also be okay if I have 5 spades. So there's like 2 different situations that are going to be successful. So I'm going to find the probability of one, and then I'm going to find the probability of the other and add those together. So the adding and multiplying can get confusing, but it's like, think of it as like different situations. Let me turn this off for the recording.